Okay, so in this problem, we are given ask and end cost and then flat cost. So, for example, we can be given something like this. The input is just ask is a binary string, and end cost and flat cost are both an integer, and we should return 6 at the end. So what does that even mean? So ask is just a binary string, and end cost is a cost that we use, and flat cost is like the flat rate that we used. So let me explain a bit further. So let's assume x equals to the number of 1, because remember s is a binary string, and then L is just the length of s. So let's assume we have these two things. The first thing we need to take note of is that when x equals 0, we return flat cost. This is how the flat cost is used. Let me try to do that. X is the number of 1 here, and else we just return L times x times end cost. Okay, so if you just look at this, you might think this is such an easy problem, but it's not. There's one like additional criteria, is that when L is even, we have one more option. So basically when L is even, it means that the length of S is even. We can choose to split S in half and solve them separately. So basically, what I'm trying to say is that, well, let's assume that you have something here. Answer is based on this one. And once you have that, and additionally, if L is even, we have one more option. So basically we can just say something like answer equals answer min, answer like solve S2, and then plus solve S22. So well, actually just use this 0 L divided by 2. So this is the first half, and this will be L divided by 2 dot like L. Yeah, so that basically it. You just solve the first half and the second half kind of recursively and see if it can have a better result. If it has, then we just return it. And if I just return that, yeah, that's basically the idea. So the idea behind this problem is just mainly we can do split for S. Split for as many times as we want, but there's still a limit for that. Because when length S is odd, it means that we must stop here. Then we're gonna use the formula provided in the problem description to solve it in O1. It's just a simple if else and some math formula to do that. So the only non-trivial part is when length s is even, right? But even for this case, there is a certain amount of limit on how many times you can do split until it reaches the odd number or base 1. So you can think of things like this. We start from, let's say, n equals to s dot sized, and then first time we do n divided by 2, and the second time we do n to the, sorry, let me just move it here, n to the power of 2, and then divided by 2 again. So, and the next time we do divided by 2 and divided by 2 and divided by 2 again. So I hope you see the pattern. So it's basically like n divided by 2 to the power of x. Because n is a very small number comparatively. It's just about 10 to the power of 5. So it means that we can do not a lot of time in terms of the efficient like this. So this x must be something like 20. It should be good enough for our use case. So that's why we are going to formulate our solution like this: DFS L and then X. So this basically means the minimum cost to solve S L dot L plus n divided by 2x. So this x just represent kind of, we can use x to calculate the length that we want. So we use x specifically, but not just length, is because this x can be just 20. That's the whole reason we do that, because if you do length, you're gonna end up with something really large from time to time. Then you have to use hash map to solve it, and hash map is significantly slower than using factor, because the way now we represent a problem like this, we can just use 20 and we can basically use the 2D factor. I hope that makes sense. So back to the problem. So this, we have formula this recursion with DFS L and X, and this is just the length of that. And then what we're gonna do now is to think about the starting state. So the final answer, or the starting state that we want is just DFS 0 and 0, right? So what does that mean? The first 0 just mean we start from the very beginning of S, and x equals 0. What does that mean? It means that let me do it here, L, so this is 0, and then this is L plus, so it is just 0 plus. I'm gonna omit that. So n divided by 2 to the power of 0. So 2 to the power of 0 is just 1, and n divided by 1 is just n. So that's why I have this 0, 0 as the starting state. So it means that we're going to do this. So the FS 0, 0 is just the minimum cost that we're gonna solve from 0 all the way to n. So you're basically looking for the whole S, if that makes sense. So that's all for the base case, and let's look for the recursive step, L and X. So because we know x, as we discussed before, we are going to look here. So L is just L, R is just this one, minus 1 actually. Yeah, because well, the right boundary is like the last element in this subarray. So if you plus the length, it will be exactly one position outside of the range. So that's why we have to minus 1 back here. And once we have L and R, it's actually pretty easy to calculate the rest of the answer. So once we have L and R, then we know the length, which is R minus L plus 1. And based on length Mach 2, and then we can do something like this. Answer equals to min answer DFS L L. So this is the first half, and then x plus 1, because x plus 1 basically means that we're going to divide the length one more time, plus DFS. So this might be a little bit more tricky. Let me move it here. So this one, the right starting point is just L plus the current length divided by 2. So the current length is here. If we divide it by 2, it's going to be in the middle. Yeah. And so on and so forth. You get the idea. So this will be x plus 1 as well. And then finally, we just return the answer. I think that's straightforward enough, because we kind of have this recursion stated here. Then we kind of also analysis the time complexity as well. So the time is mostly going to be O n log n, and the space is mostly just let me see, you need to do the prefix sum as well. I forgot to mention. So x is just like prefixed RO minus prefixed L minus 1, something like that. The prefix is just a quick way for us to answer how many 1 appear in this range. So because we need this prefix away, it's going to be ON as well. Yeah, actually, because we need to do the memorization of this, so it's going to be larger than that. So it's n log n as well. So the time and space is going to be n log n. Yeah, that's basically the idea of this solution. Let's see how can we implement that. So first thing first, we're going to initialize the size of S, going to be n. And then we need to do the calculation for the prefix sum. So this is basically used to calculate the number of 1 between L and R later. So prefixed, so 0 sum equals 0 as well, I less than n, I plus plus. So if as I equals 1, then the sum we need to plus plus, and a prefix I just means the sum between index 0 all the way to I, the number of 1 between 0 to I. And we assign that to sum. After that, the prefix summary is pretty much done. We can start doing the DFS calculation. So the DFS will return a long. So long come from here. And the first parameter is going to be L, and the second parameter is going to be X, as we discussed before. So you just function DFS like this, and then we're going to have like a DP array, like a 2D DP factor. So it's 2D, so we don't recalculate the same thing over and over again. So the first dimension is going to be n, second dimension is going to be 20, as we discussed, because of the constraint, as length can go up to only 10 to the power of 5, so it's about 2 to the power of 20. And then we can do DFS. L, the first parameter is L, so we start from L, and X is like n minus 2 to the power of X will be the length of the subarray that we're going to consider starting from L. So the length, as we just said, is going to be n divided by 2 to the power of X. So if dpl x, if it is not equals to -1, it means that we have calculated that before, because the default value is -1. So if we have assigned anything before, then it means that we have already done the calculation, and just return dpl and x. And r will be l plus length minus 1. So x is the number of 1 between r and r, so we can just use the prefix array to do that. If this is 0, then it's just 0, otherwise we just minus the prefix l minus 1. So the long answer will be, so initially the answer, we can think of it like this. We're just following the formula from the problem description. If x equals 0, then it's just flat cost. Otherwise, it will be just length times x times and cost. And then we need to cast the whole thing as long. Okay. So, and then we need to check if length is even and length is greater or equal to 2. So if both are true, then we can optionally divide the subarray by 2 one more time. And so because we do that, we want to calculate if that can make us a better result. So DFS, so this is the left half of the subarray, and this is the right half. And then once we are done considering that, we can just return answer, and at the same time, sorry, it should be L and X, and at the same time assign answer to this DP array, so we don't recalculate the same thing over and over again. So the starting state will be just DFS 00, as we discussed before. 0 means the starting point, and then this is the another 0. It stands for x, so x will be used to calculate length. So here, if you look at this is 2 to the power of x. So n divided by 2 to the power of 0 is just n. So this just basically means you start from 0 and considering n size, basically considering everything in S. So that's why this is the starting state. Okay, yeah, that's pretty much it. Let's try to run that. X2. Okay, so it's already used. Let me use the capital X here. Okay, let me try to run again. Okay, wrong answer. X equals 0. So this X, this capital X as well. Let's try to run that again. So sample test case pass. Let's try to submit. Okay, so I should cast it here, or actually I don't have to cast the flag cost because it won't be very large. Let's try to run again, and let's try to submit again. Okay, yeah, that's pretty much it. So as we discussed before, the time complexity of this solution is n log n. So time is going to be O n log n. So this log n coming from this 20. I just hard coded as 20, but you can optimize it a little bit by calculate how much time it would need for you to reach an odd number or base case. You can just keep defining n by 2, right? And let's say limit equals to 0 and while n mod 2 equals 1. When it is odd, then we'll just divide it by 2. Sorry. When it is even, we just keep dividing by 2, and then limit plus plus, and then after that we do not 20 but limit here, so you can make it more efficient, but you get the idea. So I just hard coded 20. So that is for time. Space going to be the same. You just do n log n. Yeah, that's pretty much all. So it is n log n because we have to do this DP array, and it happens to be the same dimension as the runtime. So that's why both time and space will be n log n. Yeah, that's pretty much all for the solution. Thanks for watching. I'll see you next time. Bye.